Assalamu alaikum. Myself, Dr. Ansari Farzana, Department of Chemistry, J.A.T.r Science and Commerce College for Women. Welcome all of you. In previous video, we have seen about anion exchange resin, and the exchange behavior can be shown in this way: RNH3 plus OH minus plus A minus. So it is converted into RNH3 plus A minus and OH minus releases, where A is the anion and RNH3 plus is the resin cation. Anion exchange resin are further divided into two types: strong base resin, polystyrene quaternary ammonium resin is the example of strong base resin. They contain highly ionizable group such as NH3Cl, NCH3OH. The exchange capacity of strong base resin is less. The resin is effective over a pH range of 0 to 12 in basic as well as salt form. These resins are useful in fractionation of halogen alkali, vitamin B complexes, fatty acid, etc. Resin with positively charged quaternary ammonium group attached to cross-linked polystyrene framework belong to this class. Some strong base resins sold under the trade name as Dovex1, Umberlite IRA 400, Permutite S1, etc. Weak base resin, polystyrene tertiary ammonium resin. Tertiary amine resin are polyamine resin. Sometimes they have a mixture secondary tertiary amine group on the polystyrene network. The weak base resin are effective in the pH range 0 to 9. The exchange capacity of weak base resin than that of strong base resin. These resins are useful for fraction vitamins and amino acids. Some weak base resins sold under the trade name as Dovex3, Umberlite IR45, Permutite W, etc. These are some type of ion exchange resin: cation exchange resin, strong acid, sulfonic acid, weak acid, carboxylic acid, and trade names are Dovex 50, Umberlite IR120, Rexin 101, Permutite Q, Umberlite IRC 50, Rexin 102, Permutite H70. And anion exchange resin are also of two types: strong base, weak base, quaternary ammonium ion, and amino group. They are sold under the trade name as Dovex1, Umberlite IR400, Rexin 201, Permutite S1, Dovex3, Umberlite IR45, Rexin 203, Permutite W, etc. Ion exchange equilibria. The ion exchange process involves the displacement of exchangeable ion of the resin with the ion having like charge in the solution. If the exchangeable ions on the resins are represented by A suffix resin and 1 in the solution are represented by B suffix sol, the exchange process can be represented by the equation, by this equation: A resin plus B sol. It gives B resin and A sol. The process is reversible, and for ion having like charge, the selectivity coefficient K suffix A prefix B is can be represented by the equation K suffix A prefix B is equal to concentration of B resin into concentration of A sol upon concentration of A resin into concentration of B sol, where the term in a square bracket represent concentration of the two ions A and B either on resin or in the solution. The value of selectivity coefficient of different ions are determined experimentally and are useful in understanding the relativity affinities of ions towards a particular resin. In the previous equation, if the K suffix A prefix B value is more than 1, the resin will be more selective towards B ion, whereas if the value is less than 1, the resin will be more selective towards A ion. This selectivity is applicable to both cation as well as anion. If there are two or more ions present in the mixture, their separation depends upon preferential exchange behavior. The exchange of cation anion is governed by the factors such as charge on the ion, size of the ion, functional group of the resin, degree of cross-linking of resin, exchange capacity of resin, and pH of the solution. Ion exchange capacity of a resin is defined as the total number of ion active group per unit weight present in it. It is usually expressed in millimole per gram of exchanger. More the number of ion active group, more is the ion exchange capacity. The ion exchange capacities of weak acid and weak base resins are pH dependent. The ion exchange capacity of weakly acidic resin reach moderately constant value at pH values above 9, and those weakly basic resin reach constant value at pH below 5. The ion exchange capacity value are important in estimating the approximate amount of resin required in the analysis. The ion exchange capacity of cation exchange resin can be determined in the laboratory by estimating the amount of sodium ion adsorbed by 1 gram of the dry resin in the hydrogen form. Similarly, the ion exchange capacity of an ion, the amount of chloride ion adsorbed by 1 gram of dry resin in hydroxide form. The number of millimoles are calculated from sodium or chloride adsorbed by 1 gram of resin. The ion exchange expressed as millimole per gram of resin. The ion exchange capacities of some of commonly used resins are Diolite C225 Na plus form, ion exchange capacity ranging from 4.5 to 5, zeolite 226 H plus form ranging from 9 to 10, diolite A113 Cl minus form, ion exchange capacity is 4, umberlite IR45 capacity is 5. Now preparation of column for ion exchange chromatography. The column ion for ion exchange chromatography is prepared in similar way as in column chromatography. The simplest apparatus used for ion exchange is burette provided with glass wool plug or sintered glass disc at the lower end. A well-packed ion exchange column is prepared by using resin of narrow size around 50 to 200 mesh. In all the cases, diameter of the resin bead should be 1/10 of the length of the column. An ion exchange resin swells up when put into the water, hence dry resin should not be added to the column followed by addition of water. This might result in the shattering of column. Instead of resin should be stirred with water in an open beaker for several times, decanted to remove fine particle, and then should be transferred in a small portion into the column to remove trapped air bubble or fine particle in the resin bed, and to ensure uniform packing of the resin bead, it is advisable to back wash the resin bed with a continuous flow of deionized or distilled water passing upward through the lower and end of the column. This washing is continued till wash water is clear. The resin is then allowed to settle in the column and the excess water is drained off, and the level of water is always kept a little above the level of resin to avoid drying up of resin. Cation exchange resin and anion exchange resin are soaked in 2 molar concentrated HCl and 2 molar NaOH solution for 30 to 60 minutes respectively before use. Thank you for watching.